Dear students, moving on to the next topic, let us discuss about the factors that we had to consider for choosing material for a machine component when we are designing. See here some four factors are listed. You see, when we have to select a material, first thing that comes to our mind is not cost. First, it should be available in the market near us. If you are in Jalgaon and if the material is not available in any of the shops nearby, then there is no point in choosing that material. First is availability of the material. If it is available, then we can go next. Next point is the cost of the material. You see, cost also plays a significant material. Okay, so suppose you are making in a big, quantity, then even if it is available not available in Jalgaon, so you can get it from Bombay or some other place wherever it is available. You are willing to wait for it because you want the total cost to come down. You see, or the material is right, that's suitable. So you see, it depends upon how many products you are making. A few products means you won't be going to other cities for getting it. Okay, so the availability of material depends upon, I say, the quantity also, and also at the same time, uh, you see, there should not be a need for importing. Again, you can import also from other countries and other things, depending upon how many pieces you want to make, how many machines you want to make, or how many machine components you want to make, depending depending upon that. Okay, so the availability plays the is the first factor that we consider. Then the cost of the material. Say the cost plays significant role in the selection of the product. In the and the selection of the material should be selected in such a way that the total cost should be minimum and within the specified limit. See, according to the amount that you are willing to spend, or your customer is willing to spend, or the amount that is available in your pocket, depending upon that, you have to choose the material. So, cost plays also an important role. Okay, and then another consideration is the manufacturing considerations. That means, you see, you have selected a material. It could be a very hard material or something, or it could be a very sophisticated material which you cannot do manufacturing processes in your premises or in the nearby places. Okay, so then there is no point in selecting that material. This also plays an important role. Then another very important thing is the material properties of the material. You see, each material each component that we are making, so it will be undergoing some certain forces, so certain stresses will be induced in that. So our material that we are going to select should have the desirable properties. For each component, different things may be the desirable properties. Say for electrical wiring and other things, the conductivity may be an important thing. For mechanical thing, it could be the strength, or if a thing that is rotating or something, fatigue strength, and if some wearing off, or scratch proof and other things are needed, then hardness may be the thing needed. For some things, ductility may be needed. That thingy, ductility means deforming but not breaking into two pieces, like that. Okay, and in different, depending upon the different things, different depending upon the requirement for our machine component, we have to choose the material in such a way that it has the properties that are desired. So these are the four factors. No, there may be other factors also, but these are the four important factors for selecting of the material. Then now we come to the next topic, that is different types of loads. You see, types of loads can be different types. You see, here some four are listed again. Uh, One is a steady load. Steady load is a load. You see, these things you may have studied already in mechanics or strength of materials. Okay, this is a kind of revision here. Steady load. Steady load means that which doesn't change with time. Suppose you have 100 kilo weight for on the common balance, you'll be weighing on one side, on one of the pans you will have 100 1 kg weight. On the other side you may be buying vegetables or groceries or whatever they will be weighing. Okay, so this weight of 100 kg will not be changing with time. So such a load is called as a steady load. Okay, then the second one is fluctuating or variable load. See, variable means it changes with time. Fluctuate means it is not steady. See, on a graph, if you plot, it won't be a straight horizontal line, but it may be going up down, like that. It can be a regular load like a sinusoidal load, or it can be a haphazard load. You see, if some wind is blowing and hitting our door of the house, you see, is it that the impact is always the force is always steady? It will be fluctuating at different times, different things. Okay, so this is the second kind of load, fluctuating or variable load. Okay, see here what is written is a load is said to be live. It is also called a live load. Is it dead load? See, this is a steady load is a dead load. Dead load means is a dead person won't move. Similarly, dead load will not change, whereas live load changes with time. Live means you'll be moving there, here and there. A live person can move here and there. See, so a load is said to be live or variable when it changes continuously with time. Okay, and then next one is the suddenly applied load or shock load. Suddenly applied load means, you see, suppose I have put some weight on your head, but I have not yet left it. It is still, my hand is holding it. Okay, only that it is touching your head. See, still the load has not come upon your head, and the moment I release my hand, all the load suddenly comes on your head. See, that is a suddenly applied. Okay, see, what is it written here? It is the type of load which suddenly applied rapidly build up stress in the component. Okay, some example is given here. Okay, next, moving, that is suddenly applied load. That means what? You see, if you plot a graph against say load on the y-axis and on the x-axis, if you take time, you see it may be 0 for some time, and the moment it is applied, it will be a step. Okay, just vertically it will move, and then again horizontal. So see, a step load or suddenly applied load or shock load. Okay, then another one is impact load. Impact load means, you see, like if you take a hammer and hit, you see, that is an impact load. See, when two vehicles on the road dash head on, you see, why the damage is taking place because of the impact. You see, it's just suppose two cars are just they are very close, and they touch each other. Will there be so much destruction? No, but when two are coming at a fast speed from opposite directions and suddenly come and dash, oh, how much is the destruction, how much damage takes place? People die, and vehicles are not come completely damaged. Okay, so that is because of that impact has so much this thing. See, like hathode mar, ye jo hai na, that is impact load, the instantaneous arrest of falling of mass or shock meeting two mating parts. This type of load have initial velocity like a blow of a hammer, impact of punching machines. You see, suddenly with force it is coming and hitting. Okay, like in a drop hammer or something like that. Hmm? So if it comes and hits, then it is called as impact load. These are the four different types of loads. Okay, next we come to the topic stress and strain. Yes, this also you have studied. I think you must have studied in physics also, mechanics also you must have studied, and in some strength of materials also you must have studied. And again here, I know so many times it is repeated because it is such an important topic. Okay, for a mechanical engineer, all about stresses and strains only. Okay, so let us define what is the stress. You see, stress is when an external force is applied in a body, some internal forces of resistance are developed. Okay, these internal forces can be termed as stress. Okay, I'm not describing much. Say just if you pull one, uh, if somebody pulls your hand, okay, your inside your hand some stress is developed, and it is a kind of stress, that is tensile stress. Okay, we'll see types of stresses later. This is defined as the stress mathematically. If you want to say, stress is force upon area. Force, which is normally given by newtons, and the area which is given by meter square. Okay, so this is Newton per meter square, like that. That will be the unit of stress. Then again, strain. Strain is, you see, the deformation per unit length that takes place because of that force. Some force is applied. Say somebody comes and presses you. What? You get deformed. Some change is taking place. So you are strained in that case. Say like that. Strain means change in length upon original length. This length can be positive length, positive change, or negative change. You see, if it is tensile, it will become positive change. If it is a compression, it will be negative change, and upon the original length. So this is delta L upon L. You see, delta L is given in meters. L is also given in meters. The unit of stress is, just meter cutoff, and the stress has no unit. So stress has no unit, and this is the strain has no unit. Stress has Newton per meter square. Okay, so this is how we define stress and strain. Now next let us come to the stress strain diagram for ductile materials. I believe you have studied already. You must have studied. Okay, and um, this is the stress strain diagram for the for what? For ductile material. You see, this is applied on applicable for ductile material like mild steel. Mild steel is a ductile material. So stress strain diagram, this is a very important diagram. Okay, says this is a very important from mechanical engineering point of view. Okay, other engineers also, they may be interested, like civil engineers and all, but mechanical engineers, for them this is an important diagram. So you see, on x-axis you have strain, you plot strain. On y-axis you plot stress. Okay, and you may have gone to the APM lab. In that you have a UTM machine, that is universal testing machine. So there is a specimen, and that specimen is held between two jaws, and then the specimen is pulled apart by the hydraulic actuator. Okay, when it is pulled, then automatically in the, the uh, it is connected to a computer. On the computer, a plot will be plotted. So that plot looks like this. Okay, so this is the result of one specimen. This is, with one specimen you can get the entire chart. And um, and it may not be exactly as clearly defined as like this for all the materials. Okay, but when we are explaining, we show a stress strain diagram for ductile materials in this fashion. Okay, now let us see what are the various points on this chart. Okay, you see, suppose you start from 0 and you are increasing load. Actually what we are increasing is load, is we are increasing, but load is directly proportional to the stress. Okay, because stress is what? Load upon area. Okay, so load is increasing means stress is increasing. So stress load is increasing. Okay, initially no load, then load is increasing. That means 100 newtons, 200 newtons, 300 newtons, 400 newtons. Accordingly, stress will be also be increasing. So that is plotted here. And initially, it is not elongated at all, so there is no strain. Okay, so when there is zero load, zero strain. Okay, but when load is increasing, stress is increasing, strain also starts. Okay, and you see initially this is a straight line. Straight line means a linear relationship. That means what? The slope is constant. Slope means what? This delta y and delta x, delta y upon delta x, this is the slope. Okay, that you take anywhere at this stage, at this stage, at this stage, up to a anywhere, so it is uniform. So the slope is uniform. That means this is a linearly it is varying. So this, what is that point a up to which this property we are seeing, that a is called as, you see here, you can see a is called as proportional limit. A is the proportionality limit. That means, in this region, stress is directly proportional to strain. Okay, and this is where the Hooke's law, you must have read about Hooke's law. Hooke's law is valid in this region. Stress is directly proportional to strain. Okay, that means what? Stress is increasing, strain increases, stress decreases, strain decreases. That is what is the meaning. If you are saying stress is directly proportional to strain. Okay, now after point A is reached, further you are increasing the load, that is stress is increasing, but this takes a little curve here up to B. Okay, and this B is called as the elastic limit. B is the elastic limit. Okay, B is elastic limit. See, what is elastic limit? You see, elastic limit means, at that place, if you release the load, it will come back to its original shape and size. So in that case, we call that material an elastic material, and that is the point B, which is the elastic limit. So if you cross that point further and go, then that's all. You will not get the original shape. So it would have elongated a little. Permanent elongation would have taken place. So from next further, if you increase the load, what happens at C you get an upper yield point, and at a D you get a lower yield point, and E you see ultimate stress, and F you see breaking stress. You see what? It starts yielding. So in the computer it will be shown, in the UTM machine it will be shown suddenly up to here, and then suddenly it shows a fall, because it would have yielded suddenly, suddenly would have yielded. So your computer would not have been so quick um, to find out the stress there. Okay, so there is a sudden fall here, and so that's why there are 2 points here, upper yield point and lower yield point. And after that, again some what um, further we see the graph will go like this, and further it goes increasing, increasing, increasing. But on this, from C onwards, from B onwards, after B, it is increasing. That means, when you remove the load, it will not come back to its original shape. And here it will experience maximum load, that is called the ultimate point, ultimate point. That means ultimate stress or ultimate load, it will show here. And further, if you increase, it will break it to, and that is called as breaking stress, F. Okay, so this region 0 to B is called as elastic region, and B to F, this is called as plastic region. Okay, this much you should keep in mind about the uh, ductile materials. Okay, next we will discuss about the brittle material in the next class. Thank you.